All right, in section 1.1, we had talked about some ideas of where we let things get really close together or things get really, really small. That process of letting things get really, really close or really, really small is an idea of something called a limit. So what we're doing in 1.2 is we're going to look at finding limits, specifically in two different ways, okay? One way is graphically, okay, so when we're given a graph or when we're looking at a graph in our calculator. And the other way is numerically, that's tables. So when you see numerical, you should be thinking tables, right? So the first thing I'd like to talk about is what a limit actually is. So a limit is a y value that you approach, but you may or may not touch. So imagine going to McDonald's or Starbucks or Taco Bell, I don't care, pick your favorite place. And you're driving there, but you're going through the drive-thru. I mean, you get your food and everything, but you never really actually went inside. But for all practical purposes, you got there, right? You arrived, but you didn't quite, right? That's a limiting idea. You got very, very close. You pretty much were there, but you never went in the building. There are three types of limits. There's limits that come from one direction, the left and the right. That's two types. And then there's limits that come from both directions at the same time. So if you see this notation where it says limit and it has a plus sign, 3 plus, that means you're coming from the positive side of the graph over here, right? This is the positive side of the graph. And if you're coming from this side of the graph, that's why it says plus. So you're starting on the positive side of the graph. You're moving left. Please be clear about that. You are moving to the left, but you're coming from plus, from the positive side of the graph. If you see it say that it has a negative, that's a left-hand limit. It means you're coming from the left-hand side, right? The negative side of the graph. Again, you're moving to the right. You're moving positive, but you're coming from the left. So this plus and this minus indicate the direction you're coming from. And then if it doesn't have anything after it, it means you have to come from both ways. And that's actually what we were doing on that last problem that we did in 1.1. We were coming at it from the positive side, right, the 2.01, 2.001, those kind of values, and from the negative side, values that are slightly smaller, 1.9, 1.9, and we were coming at it from both directions. So without a plus or minus after it, we have to approach from both sides. Am I good to go to the next one? Yeah? Okay. So we actually would say that a limit exists if the one-sided limits from the left and the right are equal. So if you come from the right side and you come from the left side and you arrive at the same location, then the limit exists. So what are things that can happen for a limit to not exist? Well, maybe you're coming from the left and you're approaching the value of 2, and you're coming from the right and you're approaching the value of 4, right? So there's this jump in the graph. That would mean the limit doesn't exist. Maybe there's an asymptote there. If there were an asymptote there, the limit wouldn't exist. Open circles are fine as long as the open circle is approached from both ways. So if you're coming at it from both directions and they're meeting, but they're meeting at an open circle, that's okay. That's not a problem. It's the disconnect that's the problem, okay? So another way that you see this written sometimes, just so that you're aware in terms of notation, is that sometimes people will say the limit as x approaches a of f of x is equal to L if and only if the limit as x approaches a from the left side of the function equals the limit as x approaches a from the right side of the function. That's the notation for this description, right? saying that this limit, that's both sided, because it doesn't have any pluses or minuses after the a, happens, and it works, and it exists. And it only exists if the left and the rights are equal. So we're going to look at a graph. So our graph looks something like this. And we have 5 different values we're going to find. They are all, well, the first 3 are hinging around the value of x equal -1, and that's right here, yeah? Okay, so the first one says x approaches -1 plus. What does plus mean? From the right. So we're starting on the right-hand side and we're getting closer, yeah? So we're over here, moving toward what shape specifically? What are we getting close to? An open circle, right? Looks like it's not filled in. But what y value does that open circle represent? 2, right? It's at a value of 2. This looks like it's at about 2 right here, I'd say. So when we're looking at part A, where we're approaching from the right, this is at 2. It's just the y value I'm getting close to. The second one says it wants the limit, again, approaching -1, but it's from the left. So I'll change colors. It's over here. From the left-hand side, we're getting close to a filled-in dot. But what y value is represented at that filled-in dot? It's 1. So part B is 1. Okay, so what does that mean for C? From one direction I'm at 2, and from another direction I'm at 1. It means it doesn't work, right? It means that according to this definition, the limit does not exist. Right? It's not the same from the left and the right. So what do? Well, we literally write down does not exist, and an abbreviation for that is D and E. It doesn't exist. Now, on the other two, you'll notice that they just give us the both-sided parts, right? They don't ask us from the right and from the left beforehand, like they did on A, B, and then C. But it still means the same thing. We still have to come from both directions. So looking at my graph, this one says -2. Well, -2 is right here. And if I'm coming from the right, I realize that I'm doing this, and at some point I just have to jump down, and that's okay. I just jump down. And from the left, like this, what y value are they both approaching? 1. Right? I know I jumped, but it doesn't matter. I can still do that and still get continually closer to the value I care about, x equal -2. So I'm still approaching the value of 1. How about 0? Well, if I approach from the right, I'm over here. I didn't mark 0, but 0 is the y-axis, right? And if I'm approaching from the left, I'm over here. And again, I have to jump, but I have to jump up this time. It's not a nice, neat, pretty value, so we're going to give it an estimation. What do you think approximately we're at? 2.5, 2.7, something like that, right? So do your best to give your best estimate. On my screen, which is not perfectly aligned with yours, it looks like it's about 2.7 maybe. And if you don't like that, we can actually put this to, we'll put an approximation. We definitely guessed that. But it's within the right area, right? I mean, like, it's not bigger than 2, it's not smaller than 2. I mean, like, it's not bigger than 3, it's not smaller than 2. It's between 2 and 3. So we're good to go. See you guys on Wednesday.